Let's talk about matter. And we're going to focus on differentiating between physical and chemical changes. And you'll know you got it if you can read a description or observe a change and describe with evidence if it was physical or chemical. So, what is a physical change? A physical change is a change in the appearance or the amount of a substance, but the substance is still the same. Physical changes only change the way something looks and not the actual chemical composition. Physical changes are often reversible. This means we can get back the original state. And some examples include doing things like grinding or cutting, breaking down material, mixing things together, dissolving, or making materials go through phase changes, going from solid to liquid or liquid to gas. And for physical changes, I just have to ask myself one question. Is the substance still the same? Here I have ice, which is made from water that is chilled, and if I let it melt, it turns back into the water. Is it still water? Yes. So this is a physical change. If I take that water and I add heat to it, I can boil it. Is it still water? Yes. This is a physical change. Melting and boiling are changes in the state of matter, but it's still the same substance. Here's a sugar cube. If I grind it down into a powder, is it still sugar? Yes. What if I take that sugar and I dissolve it in water? Is the sugar still there? Yes. This is just me dissolving and mixing water and sugar, but I can taste the sugar in the water. So for physical changes, the question is the substance still the same? What about a chemical change? Well, a chemical change is when I actually change the substance. So one or more substances are converted into new substances. Chemical changes actually change the chemical composition or how the atoms are arranged in the matter. And chemical changes are often irreversible unless another chemical change occurs. And some of the key examples of chemical changes are things like reacting or burning, combusting, rotting, decomposing, rusting, oxidizing, exploding, digesting, and corroding. These are all words that are examples of chemical changes. But the evidence for a chemical change is actually pretty easy to remember. And I use a sentence to help me remember what I look for evidence of chemical changes. My sentence is, please excuse coughs, burps, and sneezes, where the P reminds me to look for precipitates forming. A precipitate is when a solid forms when I mix two liquids. The E reminds me to look for energy changes. Is it getting hotter or colder or giving off light? The C is for color changes. The B is for bubbles or gases forming in a liquid. And the S is for smell changes. Unexpected smell changes typically mean a new material was made. So I can use this sentence, please excuse coughs, burps, and sneezes, to try to figure out if something is undergoing a chemical change. So here's a fire burning. What do I notice? Well, fire is hot, so there's energy changes. It gives off light. The wood is changing color, it turns black. And I can smell the burning wood. These are my evidence that a chemical change is happening. And then I can't take the ash and make the wood back into wood very easily. What about an Alka-Seltzer dissolving in a cup of water? Well, look at all these bubbles. That's a gas forming from the chemicals inside the tablet reacting with each other. What about a glow stick? Well, obviously, there's light coming off, and light is an example of an energy change. And you could argue potentially a color change. So, the biggest difference between physical and chemical is whether a new substance is forming. Physical changes only change the appearance, but the substance remains the same. Chemical means that a new substance has formed.